Yeah, hello, Siddharth.
Hi, good afternoon, ma'am. Hi, ma'am. Can you hear me?
Good afternoon. Good afternoon. Can you hear me and can you see me?
No, ma'am. I
Yeah,
can't see
yeah,
you. I
yeah.
can hear you.
Perfect. So yeah, okay. You know, we have meetings in Google Meet. So like I'm not so used to Zoom. This is
Oh,
like
is
my
it
first or the second meeting in Zoom.
in Zoom? Oh, okay.
Yeah, and I've heard. Yeah,
Yeah, but they all have
yes, okay.
some unique problems somewhere or the other.
Yeah, every time. Now we have to get used to it.
Yes,
And
ma'am.
WebEx is also there. So,
WebEx
no.
is also there. We use
All have their
Microsoft.
own different features.
Yes, ma'am. We use Microsoft Teams at work, and even
Okay.
that has its own share of problems. It is very slow at times, and sometimes it crashes. But
Oh,
so far, I think we have not received any
yeah.
with in case if we have any problems, we can try to switch, but hopefully it should be fine. Are you in Nainital, ma'am, or in
Yeah.
Lucknow?
I mean,
in Lucknow itself.
I came for the sharers. Yeah, just after the sharers, I joined. Then
Okay.
could go home because not need Diwali
Yeah.
for the weddings. So I'm here.
Acha.
Yeah,
Okay.
yeah,
So, ma'am, 1 second.
yes.
I'm going to resume recording. So, a very warm welcome to Dr. Binita Phartiyal ma'am from Lucknow, and to all our participants. I hope they will be watching the live session as well as we are streaming on YouTube as well as recording this session. So it will be available, this talk will be available for all the students and other researchers who are listening to us. And we are very, very delighted to have with us Dr. Binita Phartiyal ma'am. So Dr. Binita is working as a scientist in Birwasani Institute of Paleosciences in Lucknow, which is an autonomous institute under Department of Science and Technology in India since 2001. She has received her early education from Nainital in Uttarakhand, which is a hill station in lesser Himalayan zone for those of you who are not from India, perhaps outside. And she has a PhD degree from Kumaon University in Nainital in the year 2000. From then, she was a DARD fellow, DAAD fellow, which is a very prestigious fellowship, which is given from the German government. And she did her postdoctoral work at the University of Tübingen in Germany. And she learned environmental magnetic techniques. She's had a chance to train in some of the best laboratories, institutions, and universities in India and also abroad, with several stints at National Geophysics Research Institute in Hyderabad, National Institute of Oceanography in Goa, um, Wadia Institute of Himalayan Geology in Dehradun, and many others, NCPOR in Goa. So we can see that she has a very diverse set of experience, as well as geographically she has worked in different parts of the country as well as overseas. And her main expertise is quaternary paleoclimate, geomorphology, and neotectonics. And even though she's a geologist by training, she's a very passionate field worker, and she's worked in the Tethyan and Trans-Himalayan region. And we are very, very happy to also note that she is the first Indian woman to have taken part in the Indian science expeditions to both the poles, Antarctica as well as Arctic. So I think that's a great achievement for her, and it is a privilege to know her and also get a chance to work with her. And she's been born and brought up in the Himalayas. The mountain landscape is her home ground, her own territory, and this is where she conducts all of her research. And she's been associated with the Indian Astrobiology Group since 2016. And ever since then, we have been working under her guidance, and mainly in the Ladakh region. We have been trying to identify different sites where we can conduct studies, and her main focus has been on landscape evolution and habitation. So with this introduction, Dr. Binita ma'am, very warm welcome to the Center of Excellence Astrobiology, Amity University, our monthly webinar, and over to you, ma'am.
Thank you so much. Thank you so much, Siddharth. Yeah, I'll do a slide more. Good afternoon to all the participants here, all the astrobiology enthusiasts that are here. I'll be talking on the three poles. I know you are aware of the two poles, the North Pole and the South Pole. I'll just introduce you to one more term, that's the third pole. And before I start, I would like to thank Amity for conducting such a beautiful this course for the young students. That's very much needed, because we need people to do science in these new disciplines that are coming up all over the world, and we need it for India also, because we have such good analog sites in India. I'll be showing you some. I'll be talking about or so, and then we can have a discussion on this. So basically, yeah, as Siddharth said, I've been really lucky to have visited the Arctic, the Antarctic, and I'm working in the Tibetan Plateau region, especially the Indian side, the Ladakh region. So I'll be talking about that. I am based presently in Biglesani Institute of Paleosciences. It is Autonomous Research Institute of Department of Science and Technology, New Delhi. And it is an institute where, we do from the we deal with rocks of the very ancient rocks, like the Precambrian, we call it. When I say Precambrian, you can say like 2-3 billion years old rocks, stromatolites, early life, and to the present. We do aerosols, and we do the climatic studies, the present day data also. So we the spatial and temporal range of what our institute researches is very wide. We cover the entire Indian subcontinent, and we have programs running in the Arctic and the Antarctic too. So as I said, temporarily we cover the entire geological time scale. So that is the beauty of this institute. And the research is that, as the name tells you, paleo, it's all ancient sciences that we're doing. We're doing paleoecology, paleoclimate, paleogeography, paleophysiography, everything. And then we have about 62 scientists and several research scholars that are working in different thrust areas of the institute. So with this brief introduction about the institute, whenever you visit Lucknow, please come and visit us. And today's talk, I've just divided it in a way that, I wanted to share my experience and the opportunities and the challenges which we do, which come in our way when we study or we are working in these extreme environments. So, and their comparison to how can they become a very good analog sites for Mars. So firstly, what are the Mars analog sites? Second, Antarctica and Arctic. When I was there, what did we study? A brief, about what the research is that we conducted there. Then I'll come to the third pole with special reference to Ladakh. I'll tell you things about that place. And then what are the challenges and opportunities there? So when we say Mars analog sites, what are they? As per definition, Mars analog site, they're defined as places on the Earth that share one or more physical, chemical, or geological similarity with the Martian environments, either current or the past. So anything that looks like or resembles Mars on our Earth's surface, we can call it an analog as per definition. Secondly is that why is this analog sites, or you also call them the terrestrial sites, why are they very important? And why do we look for them? They are important because they help us to understand the geological processes on Earth, which can be extrapolated to the other solar system bodies in order to interpret and validate the data received from the orbiters or the planetary rovers. Like, every time you cannot even think to go to Mars, but to study the processes about the things that are going on there, we need to study these analog sites and what are the processes going on here. Then only we can extrapolate them to the Mars surface. And such data, researchers are doing this kind of study. So the second thing is that they are very, very important for optimizing scientific and technological needs and exploration strategies in robotic or manned mission to the Mars. So that you can test your rovers, you can test your all your machinery and in these spaces, because they have they resemble Mars and they have some kind of linkage to Mars, either the topography or whatever. We'll come to that. Then some sites are suited, you cannot get everything at one place. So some sites are suited to test instruments for exobiological research or to train sampling procedures for field exploration. So different sites have different, importance. So that's why there are many, many analog sites all over the world. And other sites, they offer extreme environment that can be used by astronauts to prepare for the difficulties in the future is space missions. So because, you know, whenever there will be a manned mission to Mars, you need to first undergo rigorous training here on Earth in these extreme environments in isolation. So that is why, you know, how you will be best prepared and to do the best research that's needed from you. So that is why analog sites are very, very important. And today we have lots of analog sites all over the world. We especially, you know, the hot water springs, the the lakes, the underwater portions, the Nemo research station is there, Arctic, Antarctic, the volcanic areas, they form very good analog sites where, you know, different kind of studies for astrobiology, for anything else, for the geology, the geomorphology, and the processes, what's happening, it can be studied. So we have lots of research stations in the United States and Canada, and we have some in Spain and South America, and these are in Africa and France. We also have research stations in Svalbard, Norway, that is the Arctic zone, the Arctic Circle here, and we also have the two analog sites in McMurdo Dry Valley in Antarctica and Concordia Station in Antarctica. So already in Antarctica and Arctic, we already have the analog sites. They have been recognized. So coming to these two places first, and then we'll go to the third pole. So it was, as I said, I was a part of the Indian scientific expedition to Arctic in 2008, and I also have gone to the, Antarctica in 2005 and 6. It was the 25th expedition, Indian expedition to Antarctica. India is a bipolar country, and we have research stations at both the poles. Both in the Svalbard region, in the Spitsbergen here in the Norway region, it comes under the polar circle, and then in Antarctica we have two stations: the Shimachi Oasis towards the northeastern side, and the Larsman Hill that's come up recently in 2012. So coming to them. Just a brief idea about what these are like. Yeah, as we all know that Arctic, it's an ocean and it's surrounded by land, and Antarctica, that is the opposite of Arctic, is a land surrounded by ocean. So, simply opposite. Arctic and Antarctic means opposite of Arctic. And when you think about the Arctic Ocean, you think that it's as it is surrounded by land. So it has been known to man since many thousand years. So the Arctic has been explored and seen since many years, but as Antarctica, it was just sighted in 1820, just 2 centuries ago, and set foot in 1895. And only since then we've started our researches in the Antarctica. Before that, we didn't even know that this continent existed, and it's the 5th largest continent in the world. Okay. As far as the population is concerned, here in the upper left panel, you see Antarctica, and wherever these red dots are, these are the countries which have stations. And in the right-hand side, you can see in orange the countries which have their research stations in Antarctica. So no indigenous inhabitants are there, only permanent and summer staffed research stations are there, because Antarctica comes under the Antarctic Treaty. There you can only do research, you cannot habitat that place. So you go there, there are no, you cannot stay there permanently, you can go do research, come back and so on. And In the Arctic, because I said, because it's surrounded by so many countries, so socially and politically, it includes the northern territories of the 8 Arctic states. So all these here, Russia and United States and Canada and Greenland and Iceland and Norway, all they have, it comes under them. So in the Arctic, there is this northernmost community, which is the research stations. There research stations of several countries are there. So researchers, they go there and do their researches and they come back. And again, it's inhabitable. You can just, the temporary research stations are there. So now the third thing comes, which is the new term that is coined, is the third pole. So what is the third pole now? Third pole, and why do we call it a pole? Because pole, North Pole and South Pole, is because of that the Earth's magnet, the outer core conductive layer, which is like in motion with the Earth's rotation and making this kind of magnetic kind of effect. That is why we call it a North Pole and a South Pole, because of that magnet. But why are we calling this place a pole? So this is a region that encompasses the entire Hindu Kush and the Tibetan Plateau and the Himalayan range. And we call it a pole because, not because of any physical reason, but because of a geographical reason, because it has ice fields contain the largest reserve of fresh water outside the poles. So Antarctica is a frozen continent. Arctic, there is lots of ice and fresh water in form of ice and snow. And after that, in the whole world, it is only this area, the third pole, that has the reserves of ice and fresh water and permafrost. So we have long glaciers like Siachen, and we have lots of lakes and in this area. So that is why it's called the pole, a third pole. So the Tibetan Plateau, it is the largest, it is the highest region on the Earth's surface, and it is a source of 10 major rivers. From this plateau, 10 major rivers, which provide irrigation, power, drinking water to about 20% of the world's population comes from this region. 20% of the world's population is around 1.3, 1.4 billion people. So this is a source of fresh water to so many. You can see the Indus River, the Ganga River, the Brahmaputra, Irrawaddy, Mekong, Salween, the Amu-Darya and the Tarim. So these are the rivers that really feed a lot of people in the Central Asia and in the Southeast Asia and China. So that is why this area is very, very important. And apart from that, it is a global ecological buffer and enormous socioeconomic and cultural diversity is seen there. Ethnic community, they reside here. They are rich in natural resources. It's a diversity hotspot, and it does have a huge population, but the Tibetan region and the higher Himalayas, there the population density is very low, where we can find some analog kind of conditions, which I will be talking about. So these were the 3 poles that I intend to cover in this talk of mine. So in Antarctica, why do we say Antarctica and Arctic as analogues? Because the climate is severe and very low temperatures are there. In Antarctica, the terrain is 98% is continental ice sheet and only 2% is the barren rock. And we have natural resources and natural hazards are too much there. We have these katabatic winds, which are called the gravity-driven winds, and they gain a speed of about 100 and 120 nautical miles, so per hour. So they are like blizzards and cyclone storms, and there is volcanism in some parts of Antarctica, and then the calving of the ice shelf, that it's breaking, that is also going on. So geographically, the Antarctica is the coldest, it's the windiest and the driest continent in the world, and during summers, more solar radiation reaches the surface at the South Pole, that is received as the equator in the equivalent time. So just imagine, so solar radiation is equal to what we receive in the equator. And as I told you earlier, that there are Antarctica is no place where one can go and live forever. So there are 45 nations signatories to the Antarctic Treaty, and they operate their seasonal and year-round stations in Antarctica. And then you all know it's 6 months of daylight and 6 months of darkness. And when it's dark, you see these auroras, beautiful night lights. Antarctica is a pulsating continent, we call it. Pulsating because sometimes it's small and sometimes it's big. How? Because in winter, the surrounding water also freezes and makes the continent look bigger. But when in the summertime, it becomes smaller. So, that is why it's known as the pulsating continent. So, as I said, India is a bipolar nation, and we have Indian scientific expeditions to Antarctica everywhere. And the institute that is in charge of that is the National Center for Polar Research, and it is in Goa. They depute scientists from all over India and who intend to work in these polar regions, and they invite projects, and they go there. Sometimes students also go there. So if they are really passionate and so see, they can just apply to and have a small project, what study they would like to do. And then they go to Antarctica. During our time, we used to take a ship from Cape Town to the Antarctica ice, the shelf area in the eastern side. And this was the ship known as Paardeberg, in which our team traveled to Antarctica. So this is the Shimachar Oasis. Oasis is here in the white continent would mean anything that is like, not white. So this is a rocky terrain, so it's known as the Shimachar Oasis. And here you have these summer stations, and this is our station called Maitri, where the winter team stays. So two teams are staying there. One is the wintering team, which stays there for 16 months, and the summer team that goes and stays there for December till March or April. So I was a part of the summer team. So I stayed for 3.5, 4 months in this place. So when you come to Shimachar Oasis, it has a dry polar climate, and the extremes of temperatures from warmest and coldest months range from 7.4 to -34, with a mean annual temperature of -10. And the warmest month is December, and the coldest is August. And blizzards, they touch a gale speed of 90 to 95 knots, and mean annual wind speed is about 18 knots. So it's a very cold, scenario there. This is, January, where the piston bully, you can see this is a lake. So the lake is frozen, and the picture that you see in the background, and the piston bully can just, go over it. So it is that cold. So we did some research here, and I was doing geomorphology, landscape evolution. I was more interested in the lakes distributed in this area. And I went for the summer expedition because I wanted to sample some of the sediments from the lake, which could tell me something about the paleoclimate of that area, which suited my institute's mandate also, and my interest also. So we did publish a few good papers from here, and this is the Shimachar Oasis. When you see it in the map, it's like, 17 kilometers like this, 17 to 18 kilometers in its length. And when you see its width, it varies from 1 to 3 kilometers. And there is this ice shelf side, and where, the ocean is there after 18 miles somewhere. And then at the southern part is the continental ice sheet, that thick ice sheet. And all these in blue, what you see scattered in the below in the diagram is in the sketch, are the lakes. They are big and small lakes scattered over the oasis area, and they are nearly 100 lakes today. And they are being they are classified into proglacial lakes that are from the continental side. All these purple areas, purple shades here are the proglacial lakes. Then there are the landlocked lakes, all the blue ones, and then the epishelf lakes, which are towards the shelf areas, or the ones marked in gray towards the north part of the sketch here. So, so three types of lakes were identified, and what our researchers told us that these were the part of bigger lake systems in the past. So, how did we come to that conclusion? Is that this is Med3. When you look at from the southern side, that is the ice shelf region, and this is the lake from where the Med3 stations gets the drinking waters are pumped into the station. So this is also known as the Lake Priyadarshini, because our expedition was started in 1981, and our the Prime Minister then, Mrs. Indira Gandhi, she started it, and we all know that Mrs. Indira Gandhi's nickname was Priyadarshini, and the lake is named after her. So this is the station, and since 1981, the station is serving very good, and every year, and it has a capacity of about, the station has a capacity about 30 people, but there are lots of summer huts outside which can again 30 people can stay there. So these are small huts where bunker beds are there and you can stay there. So these were the lakes that I was interested in, and this is the geology of the area. But basically, the rocks in this Himachal oasis are metamorphic rocks. They are gneisses, and they basically metamorphic rocks. And here you can see how the proglacial lakes, the landlocked lakes, and the epishelf lakes are over these the geological different geological suits that are present here. Metamorphic suits here. And what we did was we looked at these 5 regions that are in green. We did a sediment core from all these regions, and then the sediments looked like something like this. Somewhere you could see mud cracks and all, because it was summertime like for Antarctica it was December, Jan, Feb when we were doing this work. And then sometimes we used to dig a pit and do our sampling, and sometimes we used to take a core where it was possible. Because Antarctica is a very, it's so cold, a lot of physical weathering is there. So it was very hard to get a very smooth core where you could just find mud or clay in it. But every time you would find drop stones, you would find rubbles and pebbles and cobbles. So this is because of physical weathering. Every year there is snow, the things are frozen, the water goes into the cracks of these rocks and all, and then there is a lot of rubble everywhere. So that also disrupted our sampling things, but nevertheless we had a number of cores where we could study. And the lab in the lab, what we can do is we can date these sediments. So we did a lot of dates on these sediments, and these sediments were dated to 12,000, 7,000, 3,000, different places, different sediments. Sometimes you also got inverted dates, like the older sediment gave a younger date, and the younger sediment gave an older date. And this is very necessary to understand the process. Why did this happen? Because in these cold regions, biocryoturbidation takes place. So the younger material, it seeps through the permafrost, because it's frozen, so it just moves to the lower layers and then gives an inverted edges. So such sections we would not consider, and only the ones which we got good dates where we considered for paleoclimatic work, and others we did of course consider for the sediment characteristic work of that area. So we knew that The sediment in this area is mostly sandy, silty in nature, and it is the fills are not much. There are only about 30 centimeters to 2 meters, not more sediment in these lakes. And there were clear lenses, of course, which did tell that sometimes or the other the lake had been very stable in warmer conditions. And these sequences, and we could be able to reconstruct a paleoclimatic history from 13,000 years to 3,000 years. And what did we do? We did this again, a schematic sketch. What had happened was that about 13,000 years back, all these proglacial, there were glaciers running across this Shimacher oasis. And then as time passed, maybe 10,000 to 3,000 years, there were big lakes in the area and the glaciers had started retreating. So because of the Holocene is the time from 10,000 to today, we call it a Holocene period. So the beginning of the Holocene started with a warmer period. So because of that warmth, the glaciers started retreating, but there was lots of water. So there were bigger lakes in that region. And as of today, there are hundreds of very small lakes, and there are no glaciers as of today. And the scenario of Shimacher is what you've seen in the pictures that I just showed you before this. So today it looks like very dry, and you could see some clay bands sometimes. You could see these polygons, hexagon structures, and just typical of a glacial geomorphology. And then we also did some paleoclimatic work. We studied different parameters, on every centimeter of the samples that we had taken, and we could give a very good picture of the paleoclimate in that area. And we did compare it with the Westfold Hills, the Bunger Hills, Windmill Islands, Larsman Hills, Antarctic Peninsula, where we did have some, knowledge about what had happened in the last 10,000 years in these areas. But there were lots of gaps, and with our data we could fill in some of the gaps, and we could talk about a very constant picture right from 12,900 to 3,100 years before present. So this was one of the study. And I'm not going into the details because many of you are students here, but what these paleoclimatic studies can do is that you could point out the places where the climate was optimum, where it was okay. You cannot quantify it. We could not quantify it at that portion because we didn't have isotope data. So, but we could at least give a broader picture of what had happened in the last 10,000 years, especially in the East Antarctica region. So this was. And then in the Shimacher oasis, when you see the plant life, it is only the grasses, the Antarctic grass, the Dischampia, and we have some lichens and mosses in this area that grow, and that too only for the summer months. 2 months they'll be there, otherwise they just go under the snow or ice. The second is as I said, there is lots of physical weathering. You can see, the rocks, the hard rocks, with the wind and erosion, because of the aeolian erosion, the sand is picked up, and it's just thrown over these rocks, and in the years they form such structures where the snow petrels, they rest there. Lots of Antarctic birds are there. So this is what a typical station looks like, and you have these are the activities. You can go to the field in ski-doos. You can do field work in the boats. You have helicopters dropping you and taking you, and then the piston bullies, and especially in the Indian Antarctic expeditions, the Indian Army, Navy, and Air Force people, they are there for logistic support to the scientists. So this is February, and it gets very, very cold again. The winters are starting, summertime is over, so it's time to go. And then this, as I said, Antarctica is the pulsating continent, and the snow, it's the water. The ocean water surrounding the continent is again getting frozen. So it's time to move. Otherwise, the ship would be caught in between this freezing. The second station that I was talking to you is the Bharti, and Bharti is in the eastern side here. If you see the left hand side, the map of Antarctica, the the eastern side dot is Larsman Hills, and it can support 79 personnel. It's a very sophisticated station, and it was commissioned in March 2012. And the beauty is that, you can go via ship, and then you can just board down the ship and walk to the station. So you do not need helicopter droppings, and you're not dependent on many of the other logistics. You can just carry your work, your machines, your equipment, and you can go to the station. So, and you can sleep in the ship itself and work in this entire area. So that it's a very good, very well equipped station. And yeah, I haven't been there, and it's a dream to go there someday. And then coming to the Arctic, as I said, Arctic in the Noya-Olazat area, there are several research stations of several countries here. So we also have one Bharti, Himadri. And I was a part of this 5-member team when the Himadri was inaugurated. And this is our honorable, you can see our honorable minister who had come for the inaugural session of the, of Himadri. And this was 2008. So we already are 12 years in the Arctic also. So in Arctic, my field was more on the sediment and more on sampling, which I bring back to my laboratory to do the analysis of environmental magnetism, textural analysis, and other biotic proxies, if any. So here we did a beach ridge, but again, we were unlucky here because we got inverted edges because of bioturbidation. So we could not publish in much on the paleoclimatic work, but we also raised a core in the lagoonal areas because it was all, Arctic is all, it's about glaciers and a little river, meandering river, and then the delta. So in just 10 kilometers, you can see everything like what we see in India from the Himalayas to the Bay of Bengal of like 3,000, 4,000 kilometers. We see it in 4 or 5 kilometers in the Arctic. And the processes are the same everywhere. So that's the beauty. It's like a miniature. You're seeing everything. You're seeing a glacier, you're seeing an alluvial fan, you're seeing a river, you're also seeing an oxbow, you're seeing lots of streams, and then the delta. So this was what we did there. There is a lot of, permocarboniferous kind, the formations there. And because this area was very, very rich for coal, and coal used to be mined once in the last century here. So these deposits are very good. So coming back to, and as I already told you, that in Antarctica and in Arctic, both, they have been recognized as the analogues for Mars. So, and in analog sites, what do we do? We do science, we do engineering, we do operations, and we also look at these human factors, whether we can, we do experiments like this, wearing the suit that, you could take in the manned missions to Mars. So this is the team. They are collaborators. There is Anushri, who is here with in the NASA spaceward bound to Ladakh also. And so, like I said, Arctic, Antarctica already analogues. And now Ladakh, we'll study about Ladakh. So what is it that, you can say, how do you recognize a place that whether it could be a good analog or not? So there is kind of a fidelity test. So it would describe the resemblance of the analog to the extraterrestrial correspondent one. It is also used in comparative planetary science to express the analogy of the terrestrial site to a target extraterrestrial surface too. And the classification criteria could be, you could see the geomorphology, you could study the geochemistry and the exobiological exploration conditions there. So you have to see that. So we wanted to see whether Ladakh, that is the terrestrial analog for Mars. So we had to check the geomorphological fidelity, the chemical, geochemical, exobiological, and exploration conditions. So as we know that the red planet, Mars is dry, it's cold, it has a rocky ground. So all the researchers done till now, they tell us all this. It has some loose rock, there are grounds where, ice could be there, there were some rock glaciers, gullies, and we see folds here. And these are papers already published. People have already done research on it. And there are some volcanic rocks, quads, and shields here. And then we also have some papers of permafrost there. And there could be extremophiles organisms that thrive in very extreme conditions. So let's see where in India can we find such conditions which we can say like they are analogues for Mars. So we know, here I'm only talking about 4 sites, showing you 4 sites, but I'll talk in length about the Ladakh site. But, there are several, because India is such a huge, country. It's a subcontinent with a very diverse, physiography. We have the mountains on one side, very high mountains, Himalayas, entire 2,500 kilometer range. Then we have the arid west, we have the plateau area, and then the coastal areas and northeast and northern plains. So we have very, very diverse areas, and many biodiversity hotspots are also there. And there are beautiful sites that can be chosen for analog researchers. So the arid west, as I said, the Thar Desert in the western side, and then the run of Kutch, which is a salty, marshy land for miles and miles. You can just see that. The lunar crater in the middle state, Madhya Pradesh, and then Maharashtra, and then the entire Himalayan range. So there are so many analog sites in Mars. So now we'll go to Ladakh. So this is the Sukar Lake site, where it's a lake no more. It's a wetland now, but there was a saline lake ecosystem, and you can see the brine, the lake, the salty crust all over. Ladakh comes under the cool arid deserts. All these light red are these cold arid deserts of the world. So it's just near the equator, just near the tropical areas. You can see entire cold arid deserts here, and some in South Africa. sorry, I have a bad throat. Excuse me. So we have some in South America, and so it's a part of a very cold arid desert. So you see this. So you could see, if you've seen some photographs of Mars, you can see some. It looks exactly the same with some kind of initial drainage pattern and this. But of course, this is Ladakh, and then this is one of the sites that we studied. It's a paleo lake site. Paleo lake means a place which was a lake once upon a time in the past. So we can say that planetary exploration techniques can be studied, can be acceptably understood and well interpreted only if the processes on the terrestrial surface of our planet Earth are well studied and well understood. So to understand all these processes, how was this formed? What led to the formation of this? What is the sediment that is characterized of? How is it here? So when we understand all this here, we can say what is there on the Mars. On Mars, we know that cratered highland of moderate to high relief, isolated knobs and masses, rugged mountains, and even these rivers they have been, the conglomerates, outflow channels, they have been reported, and these are suggestive of mass movements. You can only say outflow channel can be formed when there is lots of water pressure only, then only a outflow channel will be formed. So if there is an outflow channel in Mars, so we have to say that there has to be a mass movement of a catastrophic flood kind of situation. So all these movements like mass movement, landslides, catastrophic floods, active fluvial processes, erosional and depositional work of wind, ice and water have taken place and formed the features on the Mars as they are forming it in the Ladakh region. And then the chemical analysis by Mars Pathfinder indicates that silica rocks are there, and they have differentiated parent materials. The geologists, the astrogeologists, they study on what the rock type is, what is the chemical composition of the rock, etc. Thus, Earth surface processes, they can build a strong upsurge of interest to space program, and a geologist and a geomorphologist make significant contribution to space exploration, be it the Moon or the Mars, because of their background and experience with the earthy forms, constituents, and the processes. So what the topography is, what it is made of, and what processes made this kind of a landscape, because they know about it, the geologist and the geomorphologist. So coming to Ladakh, I'll just hurriedly go to through these slides on Ladakh. And they're very interesting. So this is the newly formed Union Territory. I already told you that this region, it gives birth to 10 major rivers of the Indian subcontinent and the Tibetan Plateau region. And when we see the geology of that area, you need not get confused by this. I just want to point out here that in Ladakh area, we have all kinds of rocks. We have igneous rock, we have volcanic rock, we have metamorphic rocks. So all these we have Dras volcanics, Valamayuru formation is a sedimentary rock, and then we have the Kargil formation, which is a sedimentary rock. Again, Pangong formation comprises more of metamorphic rocks, and so on. So we have ultra basic rocks, we have ophiolites. So we have a variety of rocks that are here in Ladakh. So it's astrogeology point of view, Ladakh is a very, very important and a good site. Now coming to why as I said, the altitudes here are very high. It's above 3,000 meters above sea level. So, and it is a cold arid desert. There is no vegetation. It's above the sea tree line, and it witnesses extremes of temperature. There is intense frost action, and as I said, as in Antarctica and Arctic, Ladakh also is physical weathering is pronounced, and we have signatures of neotectonic activity. So if I take a transect from Delhi or the Gangetic Plain to right across the Himalayas, I see this kind of a profile. And the winds that the monsoonal winds, they are just blocked by the outer ranges of the Himalayas and leaving behind. This is the rain shadow zone where Ladakh comes in. So something like this. And Ladakh area, it receives precipitation in form of snow in the winter seasons, December, Jan, Feb, as snow from the winds that are coming from the Central Asia, the westerlies that you call. Okay, and the rest of India gets its monsoon from in the months of July, August, September from the Indian summer monsoon range. But when the Indian summer monsoon is intense, this also penetrates into the Himalayas and gives rain in this region, and this is very, very it's disturbing for that region because there is no vegetation to bind or hold the soil, and everything it can cause flash floods and devastate lots of hazards in that area. So basically the area is a cold, it's an arid, it has an arid climate. The major geomorphic landforms that you see are, you'll see some alluvial fans like this. You'll see moss mounds, as you call it, typical, periglacial topography. You have glacial, progrglacial lakes there. You have paleo-lake sediments also, and lots of them. And then there is fanto cutting, alluvial fanto cutting of by the rivers. Then you have present-day lakes also, which are saline. Lots of lichens and all, that kind of fauna, flora, it grows there. And these are the major landforms that one could see in that area. And there are lots of loose debris. This debris is again because of physical weathering, as there are rocks and rocks will just sliding down the slopes. And then you can see beautiful folds like the textbooks, they are there. And there is no vegetation to, obscure them. So you can really see them. And you can see the Himalayan orogeny, how, the compression has taken place, how the extensions have taken place, and so on. So as I had just said, that available evidences suggest that water was present in the form of oceans, in the form of ice caps and glaciers, lakes, rivers, flood outbursts, groundwater, and cryosphere in the Mars. So we can say that there had been long-lasting hydrological cycles in the Mars too. So these we have evidence by the topography, by the geomorphological and mineralogy that's present in the red planet. So we are kind of these are some of the pictures that show you that there is some kind of a channel structure, craters, some kind of outburst, the channel that's diverting into two, and so on. So all these pictures that come from Mars to us, so we can study them better because on field we see these structures in Ladakh. So for example, I'll give you a few examples, run through a few examples. So, this is a picture of an alluvial fan in Mars, and similar kind of, thing we see it in the Ladakh area. So we can say, after, when we study this, we can say, this was the angle, the spread was this much. So at least we have an idea of what we can interpret seeing the satellite imageries of or the photographs from the Mars area. Okay. Secondly is again another picture from Mars on the right hand side. So you see these lines that you see, and then when we were studying Ladakh, we could see the similar kind of patterns that are formed due to melting of the seasonal ice that were formed. Every year there was ice, and then when the spring season came, ice was melting, and it was just taking the finer material down, and it was almost, the slope was more than 45 degrees, and then you can form lines like this. So similarly, there is an alcove, there's a channel, and there's an apron, which can be studied and correlated to what it is in Ladakh and what it is in Mars. Third thing is the sapping. So in Ladakh also, what we were observing, that you're walking on a plain ground and suddenly there is this soil and water, it's just gone down. So so the gullies, and similarly every year this gets widened and gullies are formed, and the same process has been taking up in Mars, and groundwater sapping is creating these gullies in the Mars also. So these are two images from the Mars. Then we come to cross-bedding. So this is a paper by Sarkar et al. 2019, cross-bedding at a light-toned mound in the Juventa Chasma. So here the authors, they say that they record these, cross beddings, and similar kind of cross beddings we also see it in our fluvio-lacustrine sediments in Ladakh. This is the Spituk section. It is a fluvio-lacustrine section. It was a lake once upon a time. The time is like 12,000 to nearly 3,000, again the Holocene time, and you had a very good set of interplay of the fluvial and the lacustrine sediments here. And in that we see these cross beddings, which which we understand that how they were formed, and then we can, like Sarkar et al. In their paper, they've done the same thing. Then we see lots of meandering channels and oxbolecs on the Mars surface, and these are the cut-off meanders also, we can say. This is because we see them in the area, and we can like relate them in the cut-off meanders and the meanders we can see in the bigger rivers like the Ganga and the Brahmaputra also. So this is a very common feature for fluvial and sedimentology, person. Then, like similarly, steam is emerging out of multiple alcoves here, and similarly, we can see it in the Sarkar et al. They have again given one more of the Juliante chasma, like the stream that's originating by multiple alcoves, similarly as in Ladakh. So it is very important to know the processes what are going on in the earth, especially in such analog sites, which can be analog sites. So like the debris flow, you can just relate them, these features on our earth to these features on the Mars surface. Like they can call them a debris flow. Because you have an example, there are lots of debris flows in Ladakh, and then you can see the amount of discharge in just one flow in just 1 hour. You can have a massive discharge. So this was one where this size of rock. This is Pragya, one of the students from IIT Mumbai, and so you can see the amount of the boulder size just beyond her. So such pressure or the power these hydrological processes, the debris flows, the mud flows have, that they can bring it down. So you can, understanding the intensity and the spatial area where it can spread on, you can well interpret the ones that are in the surface of the Mars. So the arid cool desert of Ladakh has certain environments where microbial life can be studied, and the photosynthesizing microbial communities can be looked at these glacial lakes and also these environments of the hot springs. So everything, all these features we can just see on the surface of Mars, and we can also study about the microbial communities. How? Like to study psychrophiles which thrive at a low temperature, this is the best place because it's frozen for 6 months, and these glacial lakes, they are at an altitude of above 5,000 meters above sea level, and then they're frozen mostly throughout the years except for a few months, 1 month or 2 months in the summertime. So where then you can just study the psychrophiles. Then we do because ours is a paleoscience institute, and we have a very strong biotic proxy people, the expertise here. We also do analog studies of these lakes that are melted during the summertime in the Ladakh region, and the biotic distribution is basically, we have lots of algae there. So diatoms are very good proxy to study. Then Thecamabians, but Thecamabians are heterotrophs, so they tell us that the lake is quite old. They have been the primary producers. Only then the Thecamabians would thrive on them. So if you know the food chain, you can link it, and you can also see whether the lake is very new or it is a lake that has a paleoecology also. So these are some of the forms of diatoms and Thecamabians and pollens and spores. Pollens and spores of taxa that, of course, as I told you, there no trees grow in this area, but the pollens and spores of pinus and ABs, you are finding here, because they are telling you the wind direction of the southern and the western side. They're coming from Himachal or the Jammu and state, the greener Kashmir area. They come to this side and deposit in these lakes. So, and the accounts are very, very few. And then there is another feature that you see on the Mars surface are these polygons, and as I showed you in the periglacial regions. And here in Ladakh, you can see this is the highest pass of the world, Khardungla. There you can see these stone polygons, beautifully placed, and they tell about how the process, how these are formed. So then permafrost, which is very, very important. I wanted to show you these pictures. Permafrost is a frozen ground, and it has, if you would call it a permafrost if it's there frozen for a few years. So, but it's shrinking now. Our studies tell us that, the active layer is somewhere 70 centimeters to 130 centimeters. But in the future, it is just going to be some, it will penetrate down more than 1.5 meters. Maybe it could go to 3 meters also. So that's a very, very danger that we are gauging for the future. Because we called it a third pole because we had the freshwater reserve here in forms of ice, glaciers, and permafrost. And permafrost, if it degrades, so we lose this is a wealth, for the future, for future water. So we also have lots of hypersaline lakes and wetlands, and they can be, where halophiles can be studied. And then this is Sokar Lake. It was a lake. There used to be lots of water, but now over the years you can see how it is shrinking. It was a bigger lake, and then it's shrunk into two parts. And today you see moss mounds here. And there is a very good paper by Guggenheim in 2010 who has shown us the paleo shorelines. And then the paleo shoreline of the lake was 98 meters. So if you fill the sea area by 98 meters of water, you could just imagine the extent of the paleo lake. So these are things that the paleoclimatologists they do. They reconstruct the back portion, the ancient portion, what must have happened. Apart from the saline lakes, they have hot springs where the thermophiles can be studied. Thermophiles are organisms that thrive at a very, very high temperature. There are several hot springs in Ladakh. So psychophiles, thermophiles, halophiles can be studied in Ladakh, like in one place. And then you also have the aeolian deposits like the Hundar sand dunes. And this is the NASA spaceward bound team, who visited the Hundar dunes. And there between the dunes, there is, there is clay and clay deposit showing some ponding kind of a situation and a fluvial activity where cross-bedding is shown. So all these, and then we see that it's more of quartz. Obviously, it's a dune; it has to be silica, and elite because it's a cold area, area. So cold arid desert. So we get some percentage of elite in the these are the constituent of these sand dunes. And these this is the carbonate and the inorganic carbon is more, and organic is very less in this area, not only in the dunes but also in the lake sediments. We have lots of lake sediments like this. These are ancient lakes. There used to be lakes. The water has gone, leaving behind the sediment, which is layered and can be studied for paleoclimatic studies. And because of this loose materials, it is dry and there's lots of wind. So these dust devils are there to be seen everywhere. And especially after 2 o'clock, you see a lot of, because a lot of loose material is lying around the valley. So this the wind catches it up and distributes it. Wherever there's an obstacle, sand ramps are formed like this. So Ladakh is a barren, high-altitude cold desert with a Martian and a lunar topography. It features some of the best sites to study astrogeology due to extreme cold conditions, no vegetation, high altitude, and a desertic environment. The geographical setup, dynamic and active geological setting of the young mountain belt of the Himalaya, and the science capability of the Trans-Himalayan ranges support the study of astrobiology as well as astrogeology. The geomorphic features and the vast exposures of sediment can be helpful in generating data on paleoclimate, climate modeling, tectonics, Earth surface processes, and help us in a better understanding of the Martian geomorphology, hot springs, sulfur deposits, and to study the extremophiles in these environments. And the lakes and the paleolakes can reconstruct the ecological and the climatic processes involved. So with this, when we come to, we see the fidelity thing, we say that geomorphologically, geochemically, exobiologically, Ladakh qualifies to be an analog. And Amity University has recognized these, and a permanent station is coming up in the Sokar site, and it would be India's first exploration training camp, and it would be starting in 2021. So everybody should join it. It's a beautiful experience to work there. And with these words, I would say special thanks to Ranjan, Pragya, Anushri, Rakesh, and for sharing some of their photographs. And thank you everybody for being there. Thank you, Siddharth. Over to you.
Thank you so much, ma'am. I think that was one of the most comprehensive talks we have had so far that would cover all the research that takes place in Ladakh as well as the polar regions. So this is the first introductory talk that we've had that allows us to do this. So thanks a lot for that. And also thank you for a shout out to the station that is coming up. So perhaps I can just talk a little bit about that. Yeah, so I will leave the website link on the chat box. So we are working towards conducting some Mars analog training, and so basically opportunities for researchers, students, and teachers to come to Ladakh. We have attained permission to do research work in the Sokar and Puga region for 4 months every year over the next 3-year period. And we are working towards establishing the research station. But while that is being established, we want to already kickstart the activities and utilize the permits that we have. And because the station as such will be something that can support, like other Mars analog stations can support only 8 people to 10 people. But we are also looking into the possibility of camping for students who can go, and they'll be led by science leads and instructors, and they'll be given an opportunity. So we have just announced an expression of interest form, which is there on that page, and it will allow students to register themselves. And we are currently working out the different program activities that we will be conducting there. There will be different levels of activities. So for beginners, intermediate people, and advanced people, depending on whether they are very new into sciences, they are mainly looking at a basic experience, exposure to fieldwork, or if they are intermediate, they have some theoretical knowledge of astrobiology and they want to understand the fundamentals of fieldwork. And then advanced level will be more for masters and PhD students who already have some background in this and they want to work closely with the scientists. So this is just to give an overview of what we are planning to do. And this is open to students from all around. And I think the Indian students should really make use of this opportunity, because every year we see many students wanting to do astrobiology and analog research. So we are trying to put something together. So I would recommend you all to register yourselves, your interest. And those of you who have registered, we will be sending out emails with more details as to how do you sign up. And hopefully in the month of January, towards the end of January, we will be posting all the program activities so that people can book their slots. So that was all from our side. Let's see. I would encourage students to post questions. I see John has joined us as well. John, if you're with us, hello.
Hi.
Great to have you with us. Yeah. John, of course, for those of you who do not know, Dr. Jonathan Clark, he's the president of Mars Society of Australia, and he's also an adjunct faculty member at our Center of Excellence in Astrobiology at Amity University, Mumbai. And he's been the science lead now for almost 5 years, helping us design and define science activities in Ladakh. So it's always great to have you around, John. I'm going to take some questions. I'd encourage participants to post questions. I see some questions have kind of already been answered, but let's see. There's a question from Hitangshi. Have there been any evidence of metallophiles anywhere in the analog sites in Ladakh, perhaps telling us about the extremities in chemical composition in different places?
Researchers in Ladakh, as per the analogues, haven't yet started. I think starting it now, and we'll be focusing on these things. So it will be nice if you can come forward and give us some short projects which can be taken up in different sites, because Ladakh as a whole is a big geographic area, and there, as I told you, the geology also it's different there. We have all sorts of rocks, so we need to see which portions can we just go for metallophile studies or the other studies. So this needs to be developed now, so it's the start. So I feel you people would do it, of course, in the coming years. We feel this should be done in Ladakh.
Exactly. So Hitangshi, I see from your questions, you've definitely got a background in geology or maybe even geochemistry. So if you're interested in working in Ladakh and if you have a project in mind, definitely do send it across, and we'd be happy to enable you to work in the region if needed. Any more questions from students or other participants? There's a question from Yeswasri. So on what basis will you select candidates? So currently we are still designing the program. It will be open for at least 3 months each year. So we are calculating how many seats are there and how many participants are coming. So if we reach a situation where the number of candidates are more and the weeks are less, yes, we will have to have a selection procedure in place. It will really depend on the merit of the project, what they are planning to do. So there will be some projects that will be listed on the website, which the students can take up. In that case, they will have to basically write to the particular, we'll be having a representative scientist for that particular project. They can write to them and work with them out a project. If they are proposing their own project, then it will be judged based on the merit of that project. And also at this point of time, we do not have like a selection procedure in place, but this is something that is being worked out. And ideally speaking, yes, we'd like to see as many students as possible to be able to visit. And it is open for 3 years. So I'm sure if somebody does not get a chance this season, there'll always be an opportunity to go again. So another question is from Satyarth. I have a background in computers and robotics, lacking my knowledge in science domains. What kind of projects will be supported? So ma'am, I would like to ask you in your field, what kind of technologies are critical for doing geomorphology related work?
So, for geomorphology, basically ours is more of a field science. And then for climate and for the biotic proxies, we do a lot of lab work also, right from maceration to looking under the microscope. And then we also do the SEM and the EDAX studies. So these are sophisticated electron microscopes and all that are there. So I don't know whether from computers and robotics we could really accommodate some people, but of course doing it if Amity or the other institutes can take part on the robotic side, we can do like the experiments on the ground. Yeah, in Ladakh, testing the like you do,
Yes,
Siddharth. So basically,
I can also. Absolutely. So I can also talk a bit about robotics. So for sure, when you're talking about Mars exploration, a lot of the surface operations have to be autonomous. So whether you're trying to navigate on the surface, whether you're trying to operate a particular instrument or a camera, or you're trying to drill, there is definitely a significant amount of robotics that is involved, whether that is a moving arm or a moving roving vehicle. So I would encourage you to read more and more about the Mars rovers that are operational right now, what kind of science instrument packages are placed on them. So even if you're not directly a science person, you're more of a technology person, you'll once you read about these projects, you'll be able to identify what are the exact requirements that are needed. There are several rover trials and rover challenges that are conducted. For this next year, we might not be able to do a comprehensive rover challenge per se, because it takes time to announce it, and at least 1 year notice period is given from the time of announcement till when the rover challenge is held. And these are also very extreme environment conditions. So we do not want to, take students there and put them under that kind of a stress right away. Maybe down the line we might plan a rover competition, but nonetheless, if you are having a group of friends and you're already working on some kind of a robotics project which involves perhaps a small rover or any kind of robotic manipulation, it could be arm scoop, for example, or a small drill, for example. You can think about those kind of things. There are several kinds of kits that are available, and if you can program something that is able to operate autonomously and complete a particular task, whether that is collecting a sample or doing a remote sensing or a spectral hyperspectral analysis, for example. And if you would like to demonstrate that, you can test it in your backyard at home, and then you can bring it after the initial tests with you to Ladakh or any analog environments, and you can talk to the scientists who are involved, who can help you identify which other kinds of target rocks they would like to have analyzed, for example, and then you can fine tune it. So these are like some ways in which I encourage students to think about how can you use your existing skills moving into the science domains. I'll also answer the next question about registration. Are the candidates supposed to form teams? So if you already have a team, you can register on behalf of the team. If you do not have a team, I would encourage you to have an individual registration. And once you have registered yourself, and later on, once we have more information, then you can form the team, because everybody has to apply again anyways when they do the final bookings, where you have to do the payment for your particular slot, and we confirm the dates for which you're arriving and all those things. So even if the team is not yet formed, I would say still go ahead and register. Okay. Any more questions? So maybe I have one question for Binita ma'am. So
Yeah.
ma'am, what is the plan for next year? Are you, because I believe the IGC was something which was going to happen this year and you are all prepared for it. And unfortunately it got cancelled. It did not happen even in November. So what is the field campaign plan for you for 2021?
2021, yeah, because we do have projects running here, and but they are more of the human climate interaction projects. And 2021 to 25, we've been asked to give new projects because the other 5-year plan begins. Yeah, we go by the government thing. So we're planning to put in a project, a small project on this, and for that maybe the Amity will be collaborating with us. And in that project, if we have an in-house project, and we can talk about it because we have a MOU now, so we can start our work for the next 4 years under that project. So
Absolutely. Yep.
that was in mind, and we've talked to the director. Let's see if it goes. Then next year we can, in August, September, we would be able to have some funds for a field work, at least a joint field work there, and take
Perfect.
some. So yeah.
Absolutely. That is very exciting, ma'am. So we can talk offline about what are the requirements, and we'd be happy to support you from our side. In terms of student opportunities, do you normally take summer interns? What kind of opportunities are there? And actually, my question should be a little more personal to you. When you were a student initially, what kind of opportunities did you take up that made you feel that, I wanted to become a scientist?
Okay. Yeah. Oh my God. 20 years, 20, 30 years down the lane, I'll have to go and pick on. Science had already always, fascinated me, because the mountains had fascinated me, the topography had fascinated me, the clouds, forming, and how do they come, the monsoon, everything. So yeah, I used to read a lot about it. And then because I was from a very small town, Kamau University in Nainital, it's it's a very small hill station. And then we weren't very exposed to things, but our teachers were fabulous, like Professor K.S. Valde, we just lost him. He was a Padma Bhushan, Padma Shri. So people of that stature, they had taught us geology. So they were very good in inculcating that. And then later, when we joined PhD, they exposed us, they used to send us, go to NGRI, do your samples, because as a university, my university didn't have so many facilities. So we got exposed to, so that is the best thing I feel, that one should venture a lot, even any student is coming to Lucknow, so they should make it a point to search for the institutes of their interest and just go in, because that really, it widens your scope, your knowledge. You meet people, and then things work out. So that had happened with me. And then after doing my PhD, between that I went to Pakistan for a conference, and that time was the time of the Kargil war. So I don't know how I went to Pakistan, Peshawar University. There I met my German mentor, who was chairing the session in which I was like presenting, and things worked out there. Then I went for the DAT fellow. He recommended me. So if you in this field, you have to venture, you have to talk to people, and then only you can come out with good projects, good ideas, because you have some idea, the other person has some ideas. When you join it, it becomes a big idea. So to float, and it becomes interesting for more people. Then it's not just just geology, it could be computers and robotics, and that is what astrobiology is. You need to have biology in it, physics, chemistry, everything. So I think students should do that. They should venture, and they should not have a hitch to write to the professors and anybody. They should just. And today you're living in an email. It's so easy contacting people and all. So it's so easy. Our times we used to write letters, and then it used to go and whatever. But this is so easy. So to make contacts, to discuss things virtually. So I feel this should be there. This passion should be there to connect to people, various kind of people.
Yes.
So
I think
I
I
did
think
that.
I think
Yeah.
especially field scientists I have observed are generally a lot more social and willing to work with people, because the job requires it, demands it. You cannot just stay inside your lab and close yourself off. So I think for
I-
students who are interested in becoming field workers, it is very important for you to step out of your comfort zone, not just physically but also mentally. You should be willing to meet people from other labs, talk to them, have that kind of openness to take on new things. I think that is very, very important.
yeah.
Great. Any other questions from anybody else? We have already run over time, but it has been such a enthralling lecture that
Thank
I do
you.
not even realize when the time has passed. So, any last questions? I see
Okay.
that
No.
there are some students who have also joined from overseas. Like some people have joined from South America and such. So there it's like really early in the morning. So because I see some familiar names because of our astrobiology course that was running, and there were many students from Guatemala and Colombia and other places. So hopefully once the live session is going to be recorded and sent out, so we'll have more and more
Yeah.
people watching this. Great. So I think thank you so much, Binita ma'am. It has been a pleasure as always to talk to you. And on behalf of Amity University, I'd like to thank you for taking your time out on a Sunday and talking to the students. And we'd also like to speak to other scientists at BSIP. So if there are other people who you think we should get in touch with, please do let us know as well, who can share more of their insights from their experiences working in the field.
Sure.
And thank you so much to all the participants for joining in today. And we will be back next month with another exciting webinar. So stay tuned and keep reading up about astrobiology. I think it's one of the best things that can happen to many people. All right.
Thank you.
Thank you.
Thank you.
Thank you.
Bye, everybody. Thanks for joining.
Thank
Yeah,
you.
best wishes to all of you. Yeah, bye.
Thank you, Binita. It was a wonderful talk.
Thank you, John. John, so nice of you to have patiently listened through. Oh my God, it was long, but yeah. Yeah.